Hi everyone. I think we are live. So, in today's tutorial, we'll have a look at like subscription type and like input types which we can provide in our GraphQL queries. So, uh, in the last session, we covered about the list fields like field definition and support types. So we saw that there were a scalar type, object type, query type, and then now we have mutation type. So uh, the next one is the subscription type, which is like entirely a whole concept in the GraphQL. So we will have a look at subscription later in the course because uh, it is entire concept where if I go to the link, then we see that subscriptions are long-lasting GraphQL read operation that can update their result whenever a particular server-side event occurs. So most commonly updated results are pushed from the server to subscribing client. So it is somewhat like pops up. So there will be some clients which will subscribe to a particular I would say event or any kind of like update, and then whenever the data updates they will get the updated value. So it is a live connection from the server to the client and vice versa. So for example, a chat application server might use subscription to push newly received message to all clients in a particular chat room. So suppose that you have a chat room, then you send a message, right? So whoever has subscribed to that chat room, all of them will receive the messages immediately. Because subscription updates are usually pushed by the server instead of pulled by the client, they usually use the WebSocket protocol instead of HTTPS. So we know that for real-time conversation app and like pops up, we use WebSocket, right? So under the hood, subscription also uses web socket. So we'll have a in-depth look at subscription in the upload server in the later in the tutorial. So for now, let's have a look at the next section, which is input type. So input types are special object types that allow you to provide hierarchical data as arguments to fields, as opposed to providing only flat scalar argument. So let me first start the server. Wait, we have some. So address 4000 is already in use. Okay. So if I go to localhost, yep. So we have the address already being used. If I run this query, will I get some response? Yep, so I'm getting some response. So it means the server is already running. But if I quit it, then again I'm receiving the response. So on the 4000, the upload server is already running, which is like weird because I think I quit it. So I'll have to look into how to uh, kill the port number, like service running on a particular port. So how to kill the process running currently using a port. Although it is not a problem, but like right now you can see I'm not running the app, but still it is running on the port 4000. So in the Windows, what we do, open the CMD and then run this, replace port with the, and then we have the service and then task kill. Okay, so let's do it. I hope I have installed these two things. So net stat plus plus find str and 4000. Yep, so we can see that this is the service that is running 6168. We'll copy this, and then step 2 is task kill /pid, then the port number, and then /f. The process with PID this has been terminated. So now if I go back, yep, so we can see it is I guess it is showing red. So yep, unable to reach the server because we just killed it. Nice. So now we have the control. npm start, and it will start. What is this? Already in use again. So now it is being used again. Unable to reach the server, endpoint this. If I get the book, it will not send me anything. Get book will keep executing. Fail to fetch. So Apollo server, let's debug this as well. GraphQL server port already in use. App enable 25, the only happens when connection to the DB, which is initialized timeout. I don't know why is this happening. But so let's look at, so now we can see that there is nothing running on 4000, right? This npm start is still throwing me this error. Throw unhandled error event, address already in use 4000. Okay, so where are we getting the problem for? Wait. So if I just simply run node index.js, so that one is also not running. Listen already node.js. But when I'm running the command, like to see if there is a, I don't see any process. Like for this command, I saw that on the 4000 there were some services running, right? But now I'm not getting any service, which is like also visual from here. So what do we do? but actually I'm running the command from Linux, right? And I'm checking the command from here, so that is not good. Okay, got it. So this is Windows, right? So I'm checking inside Windows, but I'm running the code inside Linux, so I will have to use the Linux way. So psor script node, not node, but let's check. Not Windows, but Ubuntu. Next time I need to remember that all my code base is running on Ubuntu and not on Windows. Windows is just for using subsystem. This command. So wait. So sudo kill 9 sudo lsof it 9000 4000. Password for Rango. I think it's a work now. npm start, and yep, it is up and running on 4000 port. So I was making a mistake that I was killing the server on and now I have killed a server. I do not know what was the server on the Windows, and that process has been killed. 4000. Okay, so leave it. I can restart the computer and then it will start again, but for now, like, I saw that I was killing the process on the Windows, but in reality the project is running on Ubuntu machine inside the virtual machine, kind of. But again, it works. Okay, but I have killed the process on the Windows machine, which is now there are some process running, right? Which is good. So localhost 4000. If I go to localhost 4000, then I'm not able to access. Yep, because I think I killed the process on the Windows machine. So what do we do now? I think I will have to restart the Windows machine, but for now let's go with the documentation, because I don't want to restart my whole machine and stop the streaming. So yep, let's have a look at the input type. Okay, so input types are special object types that allow you to provide hierarchical data as arguments to field. So an input type's definition is similar to an object's type, but it is used as input keyword. You can see that for the when we had the type of query or like object and all those things, so we were using the keyword type, but for input we'll use the keyword input, which is like a reserved keyword. So input, blog post comment, and then title, and then body. So this will tell that this particular input takes title and body. So each field of an input type can only be scalar and enum or another input type. So input blog post content. So for the blog post we'll have title, then we'll have body, then we'll have media. Then media will contain media details. Now media is another input type which contains format and URL, right? Now media format is another type, which is media format. So media format can be only two. It can be image or it can be video. And now you can see that we are using this capitalized letters, so we will have a look at those. And this is enum type. You can see that we have used the enum keyword, right? So after you define an input type, any number of different object fields can accept that type as an argument. So yep, so you may ask that why to define input type. So we saw that in the previous example we were taking all the inputs in the as a like argument to this type. So add book was taking title and then author and all those things. So suppose that we have a nested input type or like a huge list of input types. So it is not better to like put all the input type inside the brackets. So we can like decouple it from here and put the input type in their own types, which is input. So now you can see that create blog post, we have one mutation which is create blog post, which will create a blog post. So it has one field as content. Now content contains blog post content, which is a input type. So blog post content, which is an input type. So it will take a string, title as a string, body as a string, and then media. Media is another like array of media details. So it will contain format and then URL. Then media format will have two values, either image or video, right? So that is the like how we use the input type. So we can see that update blog post, right? So it is taking first argument as a like id, which is like id, unique identifier, and then content same as blog post content. So you can update. For updating, you will have to know the id of the blog post that you are updating, right? So for that you will have to know the so you will provide that id, and then it will take the content as the same as the previous, and then it will return the post object. So input types can sometimes be useful when multiple operations require the exact same set of information, but you should reuse them sparingly. Operations might eventually deliver. Yep. So um, so we can see that why input was like input type was important. Why we when we decoupled it, then how it helped us, because like we defined the blog post content input in a different like in a different input type, right? So now we can use this input type in a different mutations. So for update blog post we need the same kind of data, right? So if you want to update a blog post, then we need the title, body, updated title, and updated body maybe, and then media and all those things. So we are reusing the same input type in a two different mutations. So that is why it is always good to define input type as a separate and not like take all the arguments in a single uh, line, or like as a argument for the mutations like we are using here. We could have defined an input type for this title and author as a like book input, and then book input will contain title a string and then author a string, right? So yep, operations might eventually deliver diverge in their sets of required arguments. So whatever input type and nesting you have defined, it will take those as it is. Next up we have enum types. So we know that an enum is a similar to the scalar type, but its legal value are defined in the schema. Here's an example. So when we know that these are the certain value that this field will have, like gender will have male and female and maybe other gender as well, but they are like defined set of things. So it will contain 5 or 6 or whatever number is. So for the color, if we know that we'll only get color red, green and blue, then for these things where we know that the value will be any of these, then we can define those as a enum type. And I forgot to start the timer, but it's okay. uh, okay, so enums are most useful in situations where the user must pick from a prescribed list of options, right? So as I told, that gender and like colors and all those things. So where you are giving a user option that these are the values, you can pick any of them. You cannot pick anything apart from these. So in that case we use the enum, and the syntax for defining enum is like we define the values as all caps. So as an addition benefit, enum values autocomplete in tools like Apollo Studio Explorer. So yep. So what happens then when we query? Then we get a drop down value of enums in the Apollo Studio. Although it is not running for now because we are facing some issue. But if it was running, then I could have shown you. But it is not running because I killed the process on Windows. Okay, so leave it. So an enum can appear anywhere a scalar is valid because this relies as a string. So a type query favorite color, allowed color, enum returns value, and avatar border color, allowed color is string. So yep. What happens is that we saw that we defined this set of enum as allowed color. So an enum can appear anywhere a scalar is valid. So we can put the enum wherever we can put the scalar value. Like scalar values were like int, float, and string, and all those values, right? Which return us a discrete value. So we can put so for this you can see that this query favorite color gives us allowed color, which is a enum return value. So we can we could have put a string here, so that would be a scalar value. So wherever we can put a scalar value, we can put a enum value as well. A query might then look like this. So get avatar, and then avatar and border color, and then red. So this will be like enum value for the border color. Internal values advanced. So sometimes a backend forces a different value for an enum. So a backend forces a different value for an enum internally than in the public API. You can set each enum values corresponding internal value in the resolver map you provide to Apollo servers. This feature usually isn't required unless another library in your application expects enum value in different form. The following example uses color hex codes for each allowed colors internal. Yep. So this is a little bit like advanced concept. So some like internal values. So sometimes a backend forces a different value for an enum internally. So suppose that for the like for this example only, red, green, and blue. Suppose that you want a hex code for this red and green and blue values, right? But right now you are only sending a color as red or green or blue. But suppose that the client in the CSS is using hex code for all of its development, then what you can do, you can send another value alongside the enum values. So right now here you can see that allowed color, like at the place of red we are sending this value, then green we are sending this value, and then blue we are sending this hex code inside the resolver. So that is you can set each enum's value is corresponding internal value in the resolver map. So you can define the values in the resolver only, which provides to the Apollo server. The following example uses color hex code for allowed. So yep. So when you define the resolver for your query, then you can actually send another value alongside the color. These internal values don't change the public API at all. Apollo server resolver accept these value instead of schema value as shown. So this mean is that this is the resolver, right? So resolver for allowed color was this. So we had the enum value, and then we had the values. Then we have two queries, favorite color and then avatar. So in the favorite color you can see that we are sending the string, right? And in the avatar, we are sending like we are taking parents and arguments, and then like wait, so the internal values don't change the API at all. Apollo server resolvers accept these value instead of schema value as shown. Got it. So uh, so inside the resolver, uh, like arguments here in the arguments, so if we like I'll explore what are these parents and args and all those things inside the resolver. But we can see that args dot border color uh, is any of these values. So argument automatically contains the enum corresponding value for the enums. So we will have a look at this later, because like these concepts are like not yet covered. Like what are the arguments are there inside the resolver queries. Next up we have union and interfaces type. So I will have a look at those later, because these are like very big concepts. So I think the next concept is union and interface as well. So yep, next up we have growing with a schema. So as your organization grows and evolves, your graph grows and evolves with it. New products and features introduce new schema types and fields. To track these changes over the time, you should maintain your schema definition in version control. So like we'll use Git or those things. Most additive changes to a schema are safe and backward compatible. However, changes that remove or alter existing behavior might be breaking changes for one or more of your existing client. All of the following schema changes are potentially breaking the changes. So you will have to be very careful about what are the modifications that you are making in the schema. So like whatever you add inside the schema, so suppose that you had 10 different queries, right? And then you add the 11th query, so that will be backward compatible and it will be safe to like add another query. But if you change or remove the existing schema, then that will be reflected to the all clients. So suppose that there was a query for like getting number of books, and that contains title and suppose the description of the book. But if you change the title as a title of the book, so that keyword title and the new title changed title, so that will be reflected to all the clients. So they will be using the title keyword in the code base, but now the keyword has been changed, so that will break all of their code base wherever they are using the title. So you will have to be very careful when you change the existing schema. So in that case you will have to be considerate about like how you can like fix that, or like in not changing the schema, but you can like uh, deprecate it, and then you can inform the clients that this field will be is deprecated, and this new field has been added, and this old field will be removed in like certain amount of time, like maybe 1 year or 2 year. So this is how you are supposed to handle if you are modifying the existing schema. So removing so these are the scenarios where you can break your like code base, or like the clients might face an issue. So all the following schema changes are potentially breaking changes. So removing a type or a field, so suppose that they were using title, and now you said that okay, and now I will not contain the title field anymore, so that will break the code base in the front end, right? And then renaming a type field, as I told you. So if you decide that now the title of the book will not be a keyword title, but it will be book title or something like that, then it will also like make the front end panic, because now the title keyword does not exist. Then adding nullability to a field. Now that you decided that there was a description field, but what happened that description was not mandatory. You can just put the title of the book and then the client can use it, or like, but the description field was optional. But suppose that now you added the required field. So you added the exclamation mark right after description. So now whenever they will run the query, they will see that now the description is also allowed, I mean required. So all of their query where they were not providing description or like not using description, then it will break. So that is something that is that will be a breaking change. And then removing a field's argument. So suppose that for the mutation you were taking add book, right? So it will is for taking title and description, and then you decided to remove the description field to like add a book, then it will also be breaking change, because uh, if like now that argument is not required and still the client is sending, then it will be like throw an error. So a graph management tool such as Apollo Studio helps you understand whether a potential schema change will impact any of your active clients. So Studio also provides a field level performance metrics, schema history tracking, and advanced security via operations safe listing. So this is something which is there in the Apollo Studio itself, which will like give you a warning or something like that. So we will have a look at that later. Next up in the list we have doc strings. So GraphQL schema definition language (STL) supports Markdown embedded documentation string called descriptions. So these help consumer of your graph discover fields and learn how to use them. The following snippets show how to use both single line string, literal, and multi-line blocks. So this is something where if you want to provide extra description about your field, or like to be a very like if you want to provide a documentation for your API, right? So I told you that GraphQL is like self documenting, but in the case that it is self documenting with respect to the fields and query that are available. So client will be able to see that these are the mutations, these are the queries that I have available, and these are the fields that I'm getting. But he will not be informed that okay, what does this field means, right? So suppose that we had one query like get student data, right? And then he passes us the ID of the student, right? But then we return like designation. So what this designation mean for the student? So suppose that it might be monitor, like right? So you will have to inform the client that what this designation field means. So for that purpose we use this doc string. So what happens in the doc string is that we provide a description for the field. So description for the field, my field. So supports multi-line description of your API, which you can have a look at this. So this is how we will define, I mean describe the my field field as a like description. So this description will be visible to the client that okay, this my field means this all line, whatever you can put here. In the same way, other field description for the argument. So argument integer. So this other field is taking an argument as an integer, but you will have to define what this argument means. Like suppose that it or this argument is for age, or this or argument is number, or whatever it is. So you can define the number of the client, or age of the client, or age of the student, right? So this is how you document your fields in the GraphQL. A well-documented schema helps provide an enhanced development experience. Because GraphQL development tools such as Apollo Explorer auto-completes fields name along with description when they are provided. So yep. So as I told you that it will give you the fields, but alongside it will also give the description about those fields in the Apollo Explorer. So this one is like for the client, I guess. Yep. So like this is what the client will use. So he can see that uh, if I provide, you can see that there is a documentation section, and then what is happening? inside that documentation he can see this ID. So but we, like ID, we do not see any description right over here in the Apollo Explorer. But if we provide the description for the ID over here, description for the argument or ID, then we will see that description right over here. So the client can be very very confident that okay, like mission, so and the name, then we can provide a description like this for that name field. Then it will be the client will be able to see okay, the name means that it is the name of the missile that we are launching or the mission that we are starting. So this is how the documentation works. Next up we have naming conventions. So how do we define the like names and queries and all those things? So we saw that for the type we were using B as capital. Then for the query we can see that it is all small. Then so what is the naming convention for the uh, all the things in the GraphQL? So field name should use camel case. So whatever field name we are like writing, like this title, author and all those things, so these use camel case. So first letter should be small, and then all consecutive words that are combined, they will start with capital letters. So many graphical clients are written in JavaScript, Java coding script, all of which recommend camel case for variable names. So these are like field names, right? Variable name or fields name. So they are written as camel case. Then we have type name, should use Pascal case. So we can see that the type name was over here like book and then author and all these things, right? So these should like author of the book, then it will be author and then of and then the and then book. So this is camel case, right? So this is how we will use for the all the type names. They will use Pascal case. Then enum value should be enum name should use Pascal case as well. So if we define an enum type, so that enum, like enum colors, right? So that color was also we saw that this is also Pascal case. Like we see that A is capital and then C is capital, so allowed color, this is a enum type, right? Like in the above. So for the enum also we will use Pascal case. But for the enum values, the values that are defined like red, green and blue, those should be all in caps, all caps. So should be all caps because they are similar to constant. So we see that in a programming language, whenever we define a constant, we like try to put them in all cap, right? Because they will not change in the entire like code base because they are constant. So same goes for the enum values, because we know that these are the enum values that are there. You can choose only from those, so they are in all caps. The convention helps ensure that most clients don't need to define extra logic to transform the result written by the server. So this also helps the client to actually understand that okay, this is how like query is there and all those things. So it is easier to understand the client. Next up we have a query driven schema design. So what this does, a GraphQL schema is most powerful when it's designed for the needs of the client that will execute operation against it, right? So we saw that in the very beginning that whatever query the client execute, we define like, and so the same was there in the backend as well. So in the Apollo GraphQL server, so we defined these fields like books and authors and all those things, right? So and the query was also similar. So for the book query, we were querying the years and titles and author, so those were the same. So this is what it is being said here, that design your schema based on how data is used, not based on how data is stored. So suppose that you have stored another author of the book. Suppose that the name of the uh, field was author of the book, but in the client will probably use the author. Like for instance, you can assume that he will not use the author of the book. Then you can actually provide author just here, and in the resolver by fetching from the database, you can map the author and author of the book to the same keyword. So try to be as it is said here, that design your schema based on the how data is used, not how data is stored. So it does not matter that the title, you have stored the title word in your database, such as MySQL as uh, so title can be like main heading or something like that, anything like that. But you are not supposed to use your complex backend logic or like a complex naming convention to reflect the same on the client side, because client needs some simple data keywords to use, right? So that is why you should design your schema based on how it will be used in the client, and not how you have used in the backend, or like have you stored in your database. If your data store includes a field or relationship that your clients don't need it, omit it for your schema. It's easier or safer to add a new value to a schema than it is to remove an existing field that some of your clients are using. The next good advice is that whatever data you have in your database and the relationship between the tables or between the entities, if the client does not need it, then do not give them option right away. Try to keep it as minimum as possible, like whatever the data the client needs, just provide that one. When the client demands for the extra information that you have stored in your database, then you can add it later in this schema. So that is the recommended way, instead of defining all the relationship in your database and then using that same schema design in the database to your GraphQL schema. So that is not a recommended way. Next of example of a query driven schema, so we will have a look. So let's say we are creating a web app that lists upcoming events in your area. We want the app to show the name, dates, location of each event alongside with the weather forecast for it. In this case, we want our web app to be able to execute a query with a structure similar to the following. So we will query event list, then the name of the query is upcoming event, that is defined in the Apollo GraphQL server backend. Then the upcoming event will have name, it will have date, then it will have location, which is a nested query, which will contain again name and then again weather for that location, so temperature and description. So this is how client wants the data. Because we know this is the structure of the data that would be helpful for our client, that can inform the structure of our schema. So having look at this schema, we can see that we have a weather entity, then we have a location entity, then we have a event entity. So we can define those as separate. So event, then location, and then weather information. So we can see that we have one query upcoming event, which was like similar as here. Then it returns us event. Now event contains name and date, so type event contains name and date. Then it contains location. Now location is a nested query itself, so location will have another type which will contain name and then weather. Now weather has their own type which contains temperature and description, which are like float and string values. So this is how you will convert this query into your backend schema. So yep, as mentioned, each of this type can be populated with data from different data source or multiple data source. For example, the event type name and data might be populated with the data from your backend database, whereas the weather info might be populated with the data from the third party weather API. So it does not matter where your data is stored, we can populate all of these fields from any kind of resource. It does not have to be value stored in your database only. Now designing mutations. So okay, so let's have a look. So in GraphQL, it's recommended for every mutations response to include the data that the mutations modified. So this is the standard practice actually, is that whenever, so we saw what is mutation. Whenever we want to modify some data in the database, then the client will use mutation. So for mutation, if where were we? Okay, so suppose that you are adding a book, right? But you're not sure if the book was added or not, like, or what are the fields that were modified. And although you are providing the fields that will be modified, but still, if you want a confirmation from the backend as well that okay, now this user has this information modified. So suppose that there is one mutation, update user email, right? So this takes the ID of the user and then new email address, and then it returns user. So what happens is that whenever we execute this mutation, then we take the ID of the user and then new email uh, as a string which is required. So then we immediately return the user type to the client, so that he will know that okay, now this user has the same name but the email has been updated, and ID for the confirmation that okay, this is the ID that was modified in the backend. So a client could then execute a mutation against the schema with the following structure. So he will execute a mutation with update my user, then update user email. So ID it will give a 1, then this is the new user, and then he will ask for like give me the information that was updated. So he will ask for ID, then name, then email, and then the response will be something like that. So update user email, it will contain ID, then name, and then the new email address that has been updated. Although this isn't mandatory for a mutation response to include the modified object, doing so greatly improves the efficiency of the client code. What you could have done is that you could have sent a value as enum that okay, the data was updated or updation failed, but that is not very intuitive way or like very informative way to update the client that okay, data has been updated. If the client is able to see that okay, what are the data I sent these many like updation, but were they actually updated or not? So in that case, if you were sending that okay, data has been updated, so he will not know. He will have to run another query for like getting the information about the user, and then he will see that okay, the data has been updated. So in that case, it will be a two query for him, and even like it might not be possible that he will even run. He will just accept that okay, the data has been updated. But it is a better practice that you immediately return the data that was updated in the response as well. So this is what it is when it has been said here. And as with queries, determining which mutations would be useful for your clients help inform the structure of your schema. So structuring mutations responses. Now, how do you structure the mutations response? So that is also another very important thing that you will have to take care, that how do you structure, because you know that like modifications are always made on the front end side, right? So front end need a format which they can like trust that okay, I updated this data, now I will get these many fields for every updation that I have done. So like code like 404 202 or something like that, then success which is true or false, then message okay, the data has been updated, the student has been added, or the book title has been updated, something like that. So a single mutation can modify multiple types or multiple instances of same type. For example, a mutation that enables a user to like a blog post might increase the likes count for the post and update the liked post list for the user. It makes it less obvious what the structure of the mutation response should look like. Additionally, a mutation are much more likely than a query to cause error because they modify the data. Because like client can pass any kind of data or like something which is not accepted in the backend, so there is a highly chance that there might be some error while the mutation query is, I mean the mutation is run. So a mutation might even result in a partial error in which it is successfully modified one piece of data and failed to modify another. So suppose that someone was modifying data such as username, but that was the data of the user, so name, email address. But suppose that email was updated, but name was not updated anyhow, because like the client might have passed a number or a boolean value or something weird like that. So in that case, you can see that a partial data has been updated. So regardless of the type of the error, it is important that error is communicated back to the client in a consistent way. So to help resolve the both of the concern, we recommend defining mutation response interface. Now we will have a look at what are the interfaces actually. This interface keyword which you see here. So we'll have a look. So for now, just understand that this is an interface which we can use again and again for multiple things. So along with the collection of object type that implement that interface. So here's how mutation response might look like. So interface, mutation response, and then code, success, and then message. Now how will we use this mutation response in the mutation? So like update user email, uh, mutation response, and that implements mutation response. So what is happening, this is some kind of like importing the characteristics from there. So we saw that mutation response contains these many fields, and then we are defining one mutation or type, update user email mutation response. So it will contains code, success, message string, and then user, the user that was updated. Our update user email mutation would specify user update user email mutation response as it returns type instead of user, and the structure of the response would be following. So see what will happen. So once we run the update user email query or mutation, then how the response will change, that it will also send these fields alongside the actual user that was updated. So it will so send code 200, then it will send like success boolean value if the mutation was success or false, and then a message, the user email was successfully updated. This is how we should always send, because if we send a code for 404 or 400 or 202 and all those things, so then client just look at the code and then decide, okay, the mutation was made or not. He don't have to like look at if the name was actually changed or not. You can send it from the backend. So let's have a look. How much? Okay, we are at the end of the hour. Okay, so let's have a look at the fields that we have defined here. So first one was code. Code is a string that represents that the status of the data transfer. This is like HTTPS code. So as I said, that if it was not updated or the server is down, then he can send 500 or 404 not found and 200 and all those HTTP code. Then success is a boolean that indicates whether the mutation was successful or not. Then message is a human readable string that describes the result of the mutation, if the email address was updated or not. Then user is added by the implementing type, this type response, right, which contains user. So this is how everything is working. If a mutation modifies multiple types, like our earlier example of liking a blog post, it implementing type can include a separate field for each type of that modifies, like code, success, message, and post and user. So you can include multiple types as well, like what was the user that was updated and what was the post that was like updated. Because our hypothetical like post mutation modify fields on both the post and a user, it response object includes field both for this type. So it will now contain post as well as users, so number of likes and all those things, right? Following this pattern provides a client with helpful detailed information about the result for each requested operation. Equipped with this information, developer can better react to operation failure in their client code. So yeah, these were the main basics about the GraphQL. So now I would end the stream, and next time we'll have a look at the union and interfaces, how these things work. So we have different types and all. So yep, let's have a look at this later in the course. Like maybe tomorrow I'll live stream. So till then, bye and have a nice day.